Hello there, this is Miss Nakayama, and today's lesson is 2.7a Polynomial Inequalities. We have one objective in this lesson, and that is to solve polynomial inequalities. So, to make sure you know, a polynomial inequality is any inequality that can be put into one of the forms. Okay, what you have to remember is that an inequality means it can be less than, greater than, less than or equal to, or greater than or equal to. So any type of comparison is what makes it an inequality. So the procedures that we have, first and foremost, you're actually going to solve the equation f of x equals 0. The real solutions will be our boundary points. You're going to locate these boundary points on a number line, and that's going to divide your number line into intervals. Then we're going to choose what is called a test value within each interval and evaluate the polynomial at that number. And then we're going to use that number line, selecting the proper interval to write a solution set that satisfies the given inequality. So write those steps down. I will go over them with you. I will show you what you have to show in my lab math to get credit for this. So first and foremost, we have solve and graph the solution set x squared minus x is greater than or equal to 20. Nope, it's not greater than or equal to, it's just greater than. Okay, so we're going to solve this. Number one, solve the related equation. And I'll tell you why. I actually don't write an equation at this point. But to solve any quadratic, we have to bring it all to one side. So that means I'm going to subtract 20. And then I'm going to factor it, x minus 5, x plus 4. And the related equation would mean that x equals 5 and x equals negative 4. So those are the boundary points that are going to create my intervals. So I'm going to draw a number line. Let's see. And the first point on that number line would be negative infinity. So I'm going to have a number line like this. Okay. And I'm going to put negative 4. Let's put negative 4. Where do I have negative 4? Nope, over here. Negative 4. And then I'm going to have 5. Okay, so these are my tick marks. Those are the only tick marks that you want to put on your number line. So that's setting up the number line and creating the intervals. How many intervals do I have? I have 1, 2, 3. Okay, and then I'm going to pick a test value in each interval. That's what this negative 5 is. Negative 5, I don't know why I have a negative 5 there. That's not, should have been 0. I know what was going on. Okay, my test value is actually 0. Then I have a test value on the left, and that is negative 5. And the test value on the right is 6. Can't see that well, but I'll fix it. Okay, so if I plug negative 5 into this right here, okay, then that means that I'm going to get negative 5 minus 5 is negative 10, and negative 5 plus 4 is negative 1. All right, that is a positive number. And actually, before I go on, but anyway, the next one, when I choose 0, okay, if I put 0 in right here, I get negative 5. If I put 0 in the second factor, I get 4. Okay. Then on 6, I chose the test value of 6 over here. When I put 6 minus 5, I get 1. And when I put 6 plus 4, I get 10. Okay. So what's happening is you've got to decide whether each of these intervals is positive or negative. Okay. And if you look back up here at the beginning, when we solved it, okay, we're looking for the positive region. Well, negative 10 times negative 1 is a positive number. So I want that region. Negative 5 times 4 is a negative number. And 1 times 10 is a positive number. So the key to this, y'all got to understand, you're going to have this little box in MyLab Math. And in these intervals, it does not matter. These intervals are always parentheses. If you put a bracket, you're going to get in trouble. And granted, this problem doesn't require brackets, but I'm going to do one in a second that does. But my intervals, okay, are going to look like this. Let me get rid of this guy. Okay, these are my intervals. Okay, they go from negative infinity to negative 4. And then I have from negative 4 to 5, and then I have from 5 to infinity. And each one, you actually choose the words. I write the symbols because it's easier. But in MyLab Math, you choose the words. This one is positive, this one is negative, and this one is positive. Okay? But this is the work that supports this number line here. Okay? And I shaded. Remember we said I want the positive ones. So you think about shading this number line and that number line. That means when you write your answer, y'all, there are 2 pieces. So I'm going to have 2 intervals for my interval notation. And that's going to be from negative 4 to negative infinity, and then 5 to infinity. Okay? So that one was pretty straightforward. Look at this next example. Solve and graph the solution set x is less than or equal to 6x minus 6. So again, the first thing that we're going to do is bring it all to one side, because I got to have 0 on one side. You cannot do these problems if you do not have 0 on one side. Okay? So this time I'm going to show you another method, because a lot of people make mistakes with the quadratic formula. You have to get an exact answer, because that's what you have to put in for your intervals. So the other method that I want to talk about is something called completing the square. Pooh. Not what I meant to do. Come back here. There you go. All right. So completing the square looks like this. That is when you take and I'm going to make it an equation. I take the 6 to the other side. That's why I have a negative 6 here. And then I take half of my linear coefficient. Half of 6 is 3, and I square it and add it to both sides. And that creates a perfect square trinomial. This is that factor that I keep telling you about since P.5b that becomes x minus 3 quantity squared. And of course, negative 6 plus 9 is 3. So then I'm going to take the square root of both sides, and I find out that x minus 3 equals plus or minus the square root of 3, and x equals 3 plus or minus the square root of 3. If you don't like it, you are more than welcome to use the quadratic formula. But this is an easier method, and if you practice it, you will find out how much easier it is. All right, so in our number line, okay, we have intervals, okay, and these intervals, y'all, okay, are the only 2 solutions that we have are these right here, 3 plus or minus the square root of 3. So I hope you know that 3 plus the square root of 3 is bigger than 3 minus the square root of 3. So when I make those tick marks on my graph, I have one right here, let's say, and one about here. It doesn't matter, but my numbers, all right, there's 3 minus the square root of 3 and 3 plus the square root of 3. Put it in your calculator and find out that the corresponding decimal is 1.26 and 4.7. So when I pick my test values, I'm going to have 0, some number, make it easy, 2, and 5. 5. Pooh. That's what happens when I do too much on there. Okay, so come back here. Anyway, so you're taking, where's my 5? Here's my 5. And I'm plugging it into this equation to find out if it's positive or negative. If I put 0 in here, I got 0 minus 0 goes away, so I have positive 6. So this first region is positive 6. Then I go to the next number and I put 2 in there. So 2 squared is 4 minus 12 plus 6 is a negative number. And then if I put 5 in, 5 squared is 25 minus 30. Negative 5 plus 6 is a positive number. So these are my regions. Okay, what am I looking for? Back over here, I want those values that are less than or equal to 0. So my intervals, the reason you can't have these decimals here, okay, is that you have to give the intervals in the exact number. So when I write my intervals down here, okay, I have to write 0 to 3 minus the square root of 3, and then I have to write 3 minus the square root of 3 to 3 plus the square root of 3, and then 3 plus the square root of 3 to infinity, okay? And as we see up here with our signs, I have the negative. What? That's kind of crazy. That one's supposed to be positive. That one's positive. Oh, wait. I don't know how I did did that. Anyway, let's go here. That one's positive, that one's negative, and that one's positive. And the answer that we want is the negative region. Okay? So if you have any trouble plugging it in, y'all, you can go to the table on your calculator. If you plug in 0, you get 6. You plug in 2, you get -2, and 5, you get 1. So, I mean, I did it mentally. But use that table button on your calculator to figure out whether it's positive or negative. Okay, over here, we need the negative region. So my answer is going to be this region. But you got to pay attention because this says less than or equal to, which means this interval is actually going to have brackets on it and not parentheses. So that's where you got to pay attention. But in MyLab Math, these are always in parentheses. The final answer is only where you're going to put the brackets in. Okay, erase that, put that other one. All right, same kind of thing. Okay, last problem. Okay, notice, y'all, all right, had to set it equal to 0. I had to set it equal to 0. This one I factored. This one I did completing the square. You can use quadratic formula. This one here, we happen to think is a gimme because we have, it's already factored for you. We've done the work for you, or the problem has already done the work for you. So all you have to do is, okay, where are my boundary points? They're at 0, 2, and 7, each of those factors. So I make my number line, and my number line is going to have the points 2, 0, and 7 on them. I'm going to pick my test values. My test values, remember I got negative infinity, positive infinity, which is what you need to give your intervals. Going from 0 to 2, negative infinity to 0, 0 to 2, 2 to 7, and 7 to infinity. And then I pick my values. I'm picking -1, 1, 3, and 8. And again, y'all, you can use the table if you want to. I'm show you, if you plug -1 into this thing, this is negative. This first one is negative. 2 minus a -1 is a positive number. And -1 minus 7 is a negative number. So the number doesn't really matter so much as whether or not it's it's positive or negative. So a negative times a negative is a positive, and a positive times a positive is a positive. So that region is positive. And when I put in +1, I'm going to have I'm going to have a positive, and a negative, which is going to end up being negative. If I put in 3, I'm going to have a positive, a negative, and a negative, which is positive. And if I put in 8, I'm going to have all positive and then a negative and then a positive, which is a negative again. Okay? You look back up to this original problem. It is negative. So that means I want the regions that are negative. So when I carry these down, my negative regions, how many regions are they that are negative? There are 2, so I will have 2 answers when I write my answers. I will have 2 intervals, okay? And again, parentheses over here, brackets in the final answer. Okay, one last problem. I did this because it's in factored form. It's easy, but I hope you can tell that it's different because it's got a little square on the factor, okay? All right, it's in factored form. You set each factor equal to 0, and you still find out that your, it appears I don't have them. Hold on one second. Okay, so in the first one, this is telling me that x equals 3 or 9/2. Okay, step 2, okay, I'm making my number line. All right, and I'm going to have 9/2 is 4.5. So I have 3 here, and I have 9/2 here. And my test values, okay, the 0 is here, 4 is here, and 5 is here. It does not matter what number you put. And I put it in parentheses, y'all, because I don't want to get confused with the answers of the problem. The tick marks, these are the numbers, the only numbers that you should have in your problem. So when I come down here and write my intervals, I'm going to have negative infinity to 3, 3 to 9/2, and 9/2 to infinity. Okay, so I picked my test value, and like I said, if you need to use a calculator, use a calculator, y'all. But if I put if I put 0 in here, 3 squared is a positive number, And 0 minus 9/2 is a negative number, so this region is negative. If I put 4 in, 3 minus 4 is a negative number, but whenever I square a negative number, it's positive. 4 minus 4.5 is still negative, so this is negative. And 5, again, this is squared, so it's always going to be positive. And 5 minus 4.5 is a positive number, so this region is positive. And what do I want? I want those that are negative. Okay, so remember my signs that I put in my chart is negative, negative, and positive. And which one do I want? I want the negative. Okay, so I want those two. So there's no equal sign on here. So when I write my answer, I'm going to have negative infinity to 3 union 3 to 9/2. You can't have the 3 as part of your answer because it's not equal to. And if 3 were put into this problem, it would be 0. So if I did that too fast for y'all, please take some notes, write them down, ask me questions, come see me. But hopefully you remember and write down something very important, like you always got to have 0 on one side when you're factoring. Thank you so much for watching, and y'all have a